All right, I'm going to go ahead and get started on homework number 11, and it is called Introducing Quadratics. Okay, and in this lesson, we are going to be working with quadratic functions, dealing with different transformations, and then also talking about what standard form and vertex form are with quadratic functions, similar to linear functions that we previously have dealt with. So it won't be too much of a difference. But one of the first things to point out is that a graph of a quadratic function is something called a parabola. If you think of our linear functions, right? All of our linear functions that we had give you a line, thus why it has line or linear function, right? So we dealt with linear functions, and then we also dealt with absolute value, right? Absolute value functions, and it kind of looked like this V shape, right? Our parent function was a V shape. Well, with quadratic functions, the shape of the graph, when you graph these functions, they're not going to give you a V or a straight line. It's going to kind of give you this like U shape. The curve towards the bottom is important, right? So it's more of a U shape. And it's also called a parabola. Okay? And whenever we're graphing a quadratic function, it will give you this U shape, and it might be upside down if it has negative in front, which we'll talk about. But our parent function is going to be, so our parent function for quadratic functions is going to be what we start off with in number 1. And the parent function is y is equal to x squared. And you also might see it as f of x is equal to x squared. They're the same thing. Okay, so when we go through here, it's important to first get an idea for what this looks like, and we're going to graph it eventually as well. But we're going to start off with a table, and I'm going to have my x values. I'm going to have I'll have my f of x is equal to x squared values, and then I'll also have my f of x values. So I'll create this table. And although in the past my favorite 3 points or x values to try out were 0, 1, and 2, we're going to also need some negative numbers in this. So we're going to have to use more than just 3 points in order to see the full parabola shape. So in this example, we're going to use 7. Most of the time, I'm going to require 5, but we're going to use 7. And if I ask you to plot 7 different points, my favorites to go to are -3, -2, -1, 0, 1, 2, and 3. So that way we get values on the left side of the x-axis as well as values on the right side of the x-axis. Okay, so I'm going to go ahead and draw this out. That middle column is just my process column, just so that way we can keep all this together. All right, and then finally, once we're done, we'll graph it. All right, so I have -3, and I want to basically square it, okay, to the second power. So whenever you square something, that's just multiplying it by itself, right? So it'd be -3 times -3. So if I have -3 squared, that would give me 9. Okay? Because -3 times -3 equals 9. The same thing with number 2, right? -2 squared is equal to 4. -1 squared is equal to 1. 0 squared is equal to 0. It's important to put these parentheses around each of these values as well, because you're substituting in these values. We've been doing this all year, but just as a reminder, whenever you substitute in a value, you should be putting parentheses around it. It will be very helpful later on throughout your math career. All right, so 1 squared is 1. 2 squared is 2. I'm sorry, 2 squared is not 2. 2 squared is 4. And 3 squared is 9. All right, so I have these values. I have my x values, and for all intents and purposes, these are really your y values over here, right? So now I have my points. I'm going to go ahead and graph this. So go ahead and draw my y-axis. And I'm also going to draw my x-axis. Okay, and I lost my x values. So first thing, x is equal to -3, so I'll go 1, 2, and 3, and then up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'll go ahead and graph that about there. Okay, and that is -3, 9. Then I need -2 up 4. 1, 2, 3, 4. All right. -1 up 1. 0, 0. I'm just going through these points that we have already established using these x values over here and these y values, or f of x values, over on the right. Okay, so I have 1, 1. I have 2 up 4. And then I have 3 up 9. All right, and this is the graph of f of x is equal to x squared. And once again, this shape right here is called a parabola. Okay, not a parabola, parabola. And that's number 1. Okay, so our parent function, just as our parent function, we think back to our parent function for linear up at the top right here, was y equals x. I'll go ahead and write it as f of x, right? F of x is equal to x. And then the parent function for absolute value was f of x is equal to the absolute value of x. And now my parent function for quadratics is f of x is equal to x squared. Okay, so that is number 1. Number 2 is y is equal to -x squared. Now I could go through and create this entire process column and f of x all over again. But all this is really saying is all the values that were created on the right side over here, I'm just going to make them all negative because I have this negative out in front. And I mean, just to go through, I'll go through a few just to show you as an example. Right? If I have my f and my x and my f of x, I'll do it without a process column. Okay, if I say -3, and -3 squared we already determined, so if I have negative and then putting inside parentheses my -3 squared, using the order of operations, PEMDAS, I want to do what's inside the parentheses. I can't do anything inside parentheses, so the next thing is exponents. So I take -3 squared. -3 times -3 gives me a +9. But then I also have to bring down this negative, and I'm left with a -9. So every single one of my answers, if you look up here, right? Look up here. I got 9 before, and now there's a negative out in front, so now I'm going to make that a -9, a -4, a -1, and so on. So I'll do that, right? So I'll have -3, -3, -9, -2, -4, -1, -1, 0, 0. I'll add a few onto the bottom here. Yeah, I'll do that. And I'll say 1, -1, 2, -4, and then there'll also be 3, -9. I'll just add that on the side there. That really should go at the very bottom over there. Okay, so I'm going to go ahead and graph it. And I'm really just taking all these values, like I said, and just flipping them upside down, because the negative out in front, if you remember, all those same rules apply, where if there's a negative out in front, that really just flips everything upside down. So -3, and rather than going up 9, I go down 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. -3 down 9. -2 down 4. Whoops. -2 down 4. -1 down 1, 0. And then we got this side to deal with as well. And we talked about the axis of symmetry. I know it seems like a while ago, but we talked about the axis of symmetry just in the last lesson. But the axis of symmetry says that there will be symmetry with a parabola on each side. My axis of symmetry in this case is the y-axis, right? This line right here, because it cuts it in half and it has a reflection of one side over the other. If I were to put a line right here, a mirror, right, and look from one side to the other, it's really just a mirror reflection from one side to the other. Okay, so that's my graph of y equals -x, or you could also say f of x is equal to -x squared. Okay, all right, moving on to number 3. Okay, number 3. Now, number 3 still has us graphing the function. It says graph each function and describe how it was translated from f of x equals x squared. So we're dealing with translations. And if we look at f of x equals x squared, remember that was our parent function, right? That was our parent function for all of our quadratics. Okay, and we are going to say, all right, we had this, but now we have f of x equals x squared plus 3. So how do we get from here to here? And remember before in the last lesson, if I were to, like, I'll write this over here. If I were to say, okay, we had f of x equals x, and now we have f of x is equal to x plus 3. How did we get here? What's the translation or the transformation? Really, this was, we moved it up 3. And it's funny because a lot of you guys on the test, when we went through it, were asking me, like, I don't understand how to do this problem. And, like, you're trying to make it a lot harder than it was. I just said, I just want a direction and a number. So, like, up 1, and you circled it, and that was the answer. Sorry, up 3, and you circle, and that was the answer. So when I'm looking at this problem right here, it's saying, number 3 says, graph each function, and then describe how it was translated. So I'm going to graph it, but I'm going to do things actually a little bit backwards. I'm going to describe how it was translated right now. I don't even have to graph it yet, and I know, just from the rules from before, that this is different from my parent function up here by just adding 3 on the end, right? So with that being said, I'm adding 3 on the end. And when you add 3 on the very end, that's just moving it up 3. So we'll finish it. We'll actually, I did it backwards here because I'm doing it before graphing it. But let's just say that's my guess, right? I'm going to guess, right? Now I don't know if it's going to be the answer or not, but let's graph it, right? So just like before, instead of using 5, I'm going to use, instead of using 7 points, I'm going to use 5 this time. I'm going to use -2, -1, 0, 1, and 2. Okay, and I'll keep my process column this time. And my process column is going to be x squared plus 3. And then at the very end, my f of x. All right, and I'll draw these out like this. All right, so we'll go through the very first one. So I'll say -2 squared plus 3. -2 times -2 gives me a positive 4. 4 plus 3 equals 7. Okay, so I actually made a process column, but I'm going to do it all of them on the outside over here. So I'll say all these are going to be over here somewhere. -1 squared plus 3. -1 squared is 1 plus 3 gives me 4. Okay, 0 squared plus 3 just gives me 3. 1 squared plus 3 is still 4. Notice a pattern here, right? I'm going to guess this one's 7. 2 squared plus 3 gives me 4 plus 3, and that equals 7. Exactly. Okay, so I have these values. Let's go ahead and graph them. I'm going to make that line a little bit longer there. There you go. All right. And I went -2, up 7. 1, 2, 3, 4, 5, 6, 7. All right, so I'll move that up. And then I have -1 up 4, -1 up 4. I have 0, 3. And look at that, I moved up 3. And then 1, 4. And 2, 7. Okay, and some of you just leave this here and aren't actually like connecting the points. You guys have to actually create the parabola, create the graph, because the reason why those arrows are on the end, because the points move on forever in that direction. Okay, and this was my graph of f of x is equal to x squared plus 3. And my guess was that it's going to be up 3. And if you look at it, look, check this out. 1, 2, and 3. And I was able to move up 3. So it says describe how it was translated from the parent function, f of x equals x squared. I'm just going to simply put up 3 from parent function. Because if you remember, the parent function was like, it was like down here, it went down to there and went up. Okay, so it went up 3. The vertex, the bottom point, all the points moved up 3. But the vertex is the most noticeable, in my opinion. Okay, that was number 3. Number 4. All right, number 4 is f of x is equal to x minus 2 squared. All right, so now look, this minus is inside the parentheses. It's not like out at the end back there. So if you remember, when you have a minus inside the parentheses, it's going to be to the right. So my guess is that we're going to move everything right 2. That's my guess. And we'll come back to that later. But first, I'm going to go ahead and create my table of values. And I'm just going to do it without a process column this time. I recommend always doing a process column, but just for time's sake as well. You know what? I am going to do my processes, but I'm going to do them on the outside just to make sure. To always make sure. So I'll do that. So the first one, I get negative 2 minus 2, and then that's squared. All right, so negative 2 minus 2, that can be just written as this, right? Because there's nothing I can do inside the parentheses, so I can remove them. And once that happens, I can say negative 2 minus 2, which gives me a negative 4. I subtract 2 from negative 2. And negative 4 times negative 4 gives me a positive 16. Some of these numbers might start getting bigger. All right? And then the next one, negative 1 minus 2 squared. I can just remove those parentheses around the negative 1 and write it like this. And negative 1 minus 2 gives me a negative 3. And a negative 3 squared is 9. Negative 3 times negative 3 is 9. Okay. We'll try 0. Okay, so I'll say 0 minus 2 squared. And that gives me 0 minus 2 squared. Not sure why those lines are kind of broken. And 0 minus 2 is negative 2. All right, that's being weird. 0 minus 2 is negative 2 squared. And negative 2 squared is negative 2 times negative 2, which is a positive 4. Okay. And let's do the same for the other side, right? 1. So I get 1 minus 2 squared. And once I've done that, I'm going to remove this and say 1 minus 2. 1 minus 2 gives me negative 1. Okay, and negative 1 times negative 1 is a positive 1. All right, now notice that this isn't following the same pattern as before. You know, we're looking at this, and some of these values are not like, I guess, a mirror image of the ones above. Like you'd think, oh, 0, 0 was the vertex before, so that worked. But we're going to have to eventually add some more values in here. All right, so I'll show you. 2 minus 2 is a 0. 0 squared is 0. Okay. And then we'll try 3. Okay, I'll go ahead and add some more points down here. And the reason is, if I were to graph this right now, it wouldn't give me a parabola quite yet. And I'll go ahead, maybe I'll graph it just to show you. Right, so if I'm here, I say, all right, let me graph these points. You might start graphing them and be like, hey, what's going on? So I have negative 2, 1, 2, up 16. Oh, wow. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Here's what I'll do. I'll make this, whoa. I'll extend it. How many do I have? 2, 4, 6, 8, 10, 12, 13, 14, 15, 16. 216, and then, or negative 216, negative 1, up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. And I have a 0, up 4. 1, 2, 3, 4. And then I have a 1, 1. 1, up 1. And I have a 2, 0. See how it's starting to like flatten out a little bit? We'll see what this looks like. I'm going to try a 3. 3 minus 2 squared. Okay, 3 minus 2 is 1. 1 squared is 1. All right, so now I'm starting to see a little bit of a change here, right? because these match up. My guess, if this 4 matches up here, then I'm going to go ahead and just fill in my other points to show you. So 4 minus 2 squared, 4 minus 2 is 2, 2 squared is 4, exactly. So 4, 1, 2, 3, 4, up 4 is right here. Okay, so 5, these 4s match up. 5, 9, and it's going to be 6, 16. Okay, 5 up 9, and 6 up 16. Oh, let me draw that again. That didn't look very nice. So it took more than 5 points, but I graphed my 5, and from my original, where are these? My original 5 right here, right? After I graphed them, I was like, I know it has to be a parabola. Either one of two things happened. Either I graphed it wrong, or I'd have to add more points. So that's why I ended up adding all these down here. Okay, and it ended up working out. Right, the 9s match up, and then the 16s match up. Okay, so really, like, if you're talking about an axis of symmetry, which we're going to explore further here in the next problem, right, my axis of symmetry, it's not asking for this in this problem, but think about this. This line, that cuts it basically in half, right? And that's called my axis of symmetry, or an AOS, all right? So we're going to look at my guess. Was it moved right to? Think about it. It was originally started right here, and we moved it to the right to, which is kind of cool. Okay, so my guess was right. I would just say right to from the parent function. All right, and move on to the next one. All right. So now with these, I'm not going to have to graph them, right? I can just look at these and identify the vertex, the axis of symmetry, the maximum or minimum value, and the domain and range. All right, so my first one, I'm asking for a lot here, right? Like, why are you asking for all these different things? Well, I'll show you why in a second. So I'm writing out the problem here. F of x is equal to the quantity of x plus 2. Whenever I say the quantity of, that just means it's inside parentheses. Plus 3. Squared plus 3. Okay. And if we look at this, the things I'm asking for, right? What do I need? All right, I want the vertex. All right, so I'm saying give me the vertex. And then I also want the axis of symmetry. I'll just abbreviate that AOS. And the maximum value, so I'll just say max. And then the minimum value, I'll just say min. And the domain, what in the world is the domain? And the range. So I'm asking for 6 things just by looking at this, all right? We're gonna figure them out. All right, so the first thing I wanna do is I want to identify the vertex, and we already have this in something called vertex form, right? And vertex form is different from standard form. If you remember vertex form from linear functions and absolute value functions, then this is the same thing. We're going to have f of x is equal to a times the quantity of x minus h squared plus k. So I should say the same thing. The only difference is that squared up there. That's our vertex form for quadratics, right? So now that we have that, we know that the vertex is really just h comma k. So if I'm looking at this, I can tell that this is my h and this is my k. But realize this is a negative version of it. So my vertex, my x value is going to be a negative 2 instead of 2 plus k, which is just 3. Okay? So this is my h, and this is my k. Okay, if you're wondering why I got that negative, it's because out in front here, our vertex form, it's really a negative version of it, and really a negative version of negative 2 is a positive 2. That's why that's there. Okay, so my vertex, just by looking at this, I know is at negative 2, 3. So check this out. It's not asking for a graph, but if I were to just graph this, right? This is such a rough draft of this, but if I were to graph this negative 2 up 3, and just say, all right, well, my parabola doesn't have a negative out in front, so my parabola is going to look at something like, that's actually kind of ugly. Let me try again. That looks too much like a V. Let me try one more time. There you go. All right, let's say it looks something like this. This is a very rough sketch. But at the same time, I can now also identify, just by looking at this, my axis of symmetry. Even if I didn't graph it, I could say this, but my axis of symmetry is always going to be, so my vertex was HK. My axis of symmetry, you just write x is equal to h, okay? So I can say x is equal to, what's h? Well, we said h was negative 2. Because check this out, my axis of symmetry, if I were to draw this, goes right through when x is negative 2. See how this value right here was negative 2? My axis of symmetry cuts right through. This line, this dashed line, is at x equals negative 2. And then from here, what I want to do is I want to identify what my maximum value is. The max is going to be infinity. That's the sign for infinity, meaning it moves on forever and ever and ever. It's like a sideways 8 because these arrows keep moving up forever. That's the maximum value. These keep on moving forever and ever and ever in a positive direction. The minimum value, the lowest number I can possibly get, is this value right here. Okay, the minimum y value. Okay, and the minimum y value in this case is whatever, well, since it's a positive parabola, okay, y equals 3. All right, if you just put 3, I'd accept that as well. What is my domain? What x values are possible? Well, that's saying, all right, if I have my y values and my x values, we could choose from any x value. So I could just write all real numbers, meaning all numbers, not imaginary numbers, all real numbers. And the way you can write that is by writing, well, we'll get into that later. There's a letter that you can write in order to show all real numbers, but I'll talk about that later. It's just a simpler way, all real numbers. Then the range, okay, are all values, all the y values that are possible. Okay, so my range are all y values greater than or equal to 3. Okay, all my y values that are greater or equal to 3, because if you're looking at this graph, all the values that are greater than 3 actually fall along the graph of the parabola. Okay, it moves up and up and up infinitely. All right, so that's how I would work through number 5. Number 6. Number 6 is f of x is equal to 2 times the quantity of x, x plus 3 squared minus 4. Okay, so let's take a little look at this. All right, if I want to be able to find my vertex here, once again, this is in vertex form, so I know that this is my H and this is my K, and my vertex would be at -3, -4. My axis of symmetry is just whatever my x value was, so x is equal to -3. My maximum value, since I know it's not flipped upside down, it doesn't have a negative out in front. If it had a negative out in front, then it would be a flipped parabola where it would look something like that, but that's not the case here. So my maximum value is going to be infinity, okay? It's going to move on forever. My minimum value is going to be y is equal to -4, right? Because -4 is the lowest of the vertex, okay? My domain, there's no restriction on this, so my domain is going to be all real numbers, all right? And then my range is going to be, if I'm looking at my y values, my range is going to be all y values, all y that are greater than or equal to -4. All right. And like I said, if I were to like briefly and casually graph this, you don't need to, but right, I just graph the vertex. My axis of symmetry would cut it in half. So I know that it would be x equals -3. All the values, the maximum values are infinite. If it helps you to draw this graph, you can. You don't have to, but the minimum value, the minimum y value is all the way down here at -4. My domain, all x values are possible, right? And then my range is as long as y values are greater than -4, right? If like a -5 value came up, or a -6 or anything down below here, those are not possible. Those fall outside of the range, all right? And that's number 6. See if I can fit number 7 in down here. Yeah, I'll do number 7 on the next screen. All right, number 7. Number 7 is f of x is equal to -3 times the quantity of x minus 2 squared plus 6. Okay, and once again, the things that I want are my vertex, my axis of symmetry. It says max or min, but I'm just including both. The reason why it says that is because sometimes you have a parabola that's flipped upside down, which is going to be this one. So this one might be slightly different, just for a few reasons, but I'll show you why. So this negative out in front already is telling me that the parabola is going to be shaped like that, right? That's just what it's telling me. Okay, and by looking at that, I know my vertex here in vertex form is just going to be 2, 6 by identifying that 2 and that 6. My axis of symmetry, is just setting x is equal to 2. My maximum value, if you're thinking about this, my maximum y value would be if y is equal to 6, right? Because if 2, 6 is my graph, which I'll show you in a second, 6 is actually the highest the x or the y value can go. My minimum value, if it's a downward facing parabola, then it's going to be infinite. So that's really one of the main switches there, is switching those min and max values because it moves downward forever. My range are all real numbers. And then my range, what are the possible y values? The y values that are less than or equal to 6. Okay, and here's why. Like I said, if I have this graph, I have -2 and then up 6, 1, 2, 3, 4, 5, 5, 6, and it's a downward facing parabola. Okay, my vertex is at 2, 6. My axis of symmetry goes through where x is equal to 2, right there, right? When x is 2. My maximum value, the most it could be is 6, right? Because all these points that are like up here don't actually hit that. So the max value is 6, the minimum value, these have these arrows at the end, which means they move downward forever. And then all real numbers, that's always pretty much going to be your answer for the domain. Truly all the x values. And the range are my y values. So my y values are all the values that are less than -6, all the way down. Okay, so that's number 7. Okay, number 8. Number 8 says identify the vertex, the axis of symmetry, the maximum minimum value, and the range of each parabola. Okay, so let me go ahead here and start with number 8. So number 8 is y is equal to x squared plus 2x plus 1. Now here's the thing. We do not currently have this in vertex form. So we don't know what the vertex is. So we're going to have to start looking and identifying some things. And the first thing that I want you to identify in this, if you're looking at this in standard form and you still want to find the vertex and the axis of symmetry and the maximum value and the minimum value and the domain, and you want to find the range, all right, there's a few things you're going to have to do. It's not going to be as easy as using it just as it was in vertex form. So we're going to have to look at this from a standard form perspective, because we know that standard form is y is equal to ax squared plus bx plus c. All right, so when I'm looking at this, I know that my vertex is going to be x is equal to -b over 2a, and then my y is going to be the function of -b over 2a. And I'll explain this in a second, but the first thing you want to do is, the first step in all this, well, how do I even start this? My first step is to identify A, B, and C. Okay, so let's look at this. So my first thing that I want to identify is the A out in front here is really a 1. So I would say A is equal to 1, B is equal to 2, and my C is equal to 1 as well. All right, so I've identified A, B, and C. All right, the next thing I want to do is I want to go through and create my, I guess, how can I put this? I'll say find the x value. And the way you would find the x value is you would say x is equal to -b over 2 times a. Okay, so if I take -b over 2 times a, my b is 2, right? My b is 2 over 2 times a, which is 1. So really, that gives me -2 over 2. -2 over 2 is going to give me a -1. Okay, so my x value in my vertex, right, is going to be at -1 something. I don't know what this other value is. And the way I would find that is by substituting -1 into the original equation. Okay, so I'll say substitute x into equation to find y. All right, so I can look at this and I'll go ahead and maybe I'll erase the previous problem. That would probably be the best way to do this, right? I'll erase all this up here. All right, get that out of the way. And I'll just continue this problem up here. So I'll say y is equal to 1, and I'm substituting in -1 for x squared plus 2 times -1 plus 1. All right, so y is equal to -1 squared. I guess I want to go through the order of operations. Parentheses, there's nothing in parentheses I can do. Exponents, there's an exponent. -1 squared, -1 times itself is a +1. So 1 times 1 plus 2 times -1 plus 2. 1 times 1 is 1, plus -2 is a -2 plus 1. All right, so 1 minus 2 is -1, -1 plus 1 is 0. Okay, so -1, 0 would be my vertex. Now that I have my vertex, I can fill out everything else, right? Because I know that my axis of symmetry is x equals -1. There's no negative out in front, which means my maximum value is infinite. My minimum y value, okay, the lowest that I can go, if my vertex is -1, 0, is going to be y equals 0. Okay, because you can't go any lower than that. If you think about it, right? If I make a very rough graph here, -1, 0, all the values down there mean nothing, right? So my domain is all real numbers, and then my range are all the values where y is greater than or equal to 0. Okay, so the extra step, and I guess in this, my 3 steps down here are say how to find vertex in standard form. Okay, these are my 3 steps to do that. And that's actually what we're going to be doing in the next few problems. All right, 9 and 10 as well. All right. So number 9 says y is equal to 2x squared minus 6x plus 3. Okay, and it says that it wants my vertex, my axis of symmetry, my maximum value, my minimum value, and my domain and range. All right, so once again, we're going to follow those 3 steps. The first one is to identify my A, B, and C. My A out in front is 2. My B, make sure to include that -6. If there's a minus sign out in front, you have to include it to the B, right? And C is going to be 3. Okay, now that I have this, I know that my x value is going to be negative b over 2a. All right, awesome. So let's go ahead and substitute negative 6, because that's my b, right? And over 2 times 2. All right, so negative times negative gives me a positive 6. 2 times 2 is 4. How can I simplify this? Well, if I divide the top and bottom both by 2, I can simplify this down to 3 halves, right? Which is really just 1.5. All right, so my vertex is 1.5 something. All right, and I need to be able to figure out what that is. So let's go through here. It's going to get a little messy with the decimal here, but we'll work through it. Negative 1.5. So I'll substitute in my value. So I'll say 2 times 1.5 squared minus 6x. I'm sorry, not 6x. 6 times 1.5 plus 3. Okay, so first thing I want to do is, if I'm looking at this, I want to go through order of operations, and I want to look if I can do anything inside the parentheses, and I cannot, and so that allows me to move to the exponents. And if I'm looking at this one right here, the first one from left to right, 1.5 squared is actually 2.25. So 2, I'm bringing down the 2, times 2.25 minus, and I'm going to multiply 6 times 1.5. So I'll say 6 times 1.5, and I get 9 plus 3. Okay? And if I'm looking at this, moving left to right, use my multiplication. I guess I should have rewritten this like this: minus 6 times 1.5 plus 3. I should have done this first, but they'll all work out the same way. 2 times 2.25 gives me 4.5, right? Minus, and then we determined that was 9 plus 3, right? And then let's take 4.5 minus 9, and I get negative 4.5. And then I'm adding 3, and negative 4.5 plus 3 gives me a negative 1.5. All right, so just for the sake of graphing, to show you what this would look like, all right, and I'll just graph this quick. If I go 1.5, so that would be like, I guess I'll move 2, 1, 2. In the middle would be like 1.5, right between these two, but I'm gonna go to that point right there and then also go down 1.5. So it's somewhere like about like here. All right, there's no negative out in front, so I know it's a positive looking parabola, and that point was 1.5, negative 1.5. Okay, so my axis of symmetry is actually at x equals whatever the x value is, 1.5. My maximum value is infinite because it moves up forever. My minimum value is going to be the y value, okay, negative 1.5. My domain is all real numbers. And my range, all my y values that are greater than or equal to negative 1.5. Okay? So that one had a decimal, a little tricky, but still very possible. All right, number 10. All right, number 10 is y is equal to negative x squared plus 2x plus 5. All right, so looking at this, once again, my first step, well, I'll write out the vertex. I want to be able to find the vertex first. That helps me find everything else. Axis of symmetry, and I want to find the max. I want to find the minimum. I want to find the domain and the range. Okay, so first off, let's identify there's a negative out in front, which means it's going to be a downward facing parabola, right? And I want to find my A, B, and C. Okay, my A is -1, my B is 2, my C is 5. From here, I'm able to find my vertex by saying x is equal to negative b over 2a. Negative b is negative 2 over 2 times a, 2 times, I'm sorry, that's right. 2 times -1, which gives me a -2, okay, and that gives me 1. Okay, my x value is 1. I got to find out what my other value is by substituting it into the original equation. I'll say y is equal to -1 squared plus 2 times 1 plus 5. Okay, if I'm moving downward here, I square -1 times 1 is 1, so -1 plus 2 times 1 plus 5. 2 times 1 is 2, so -1 plus 2 plus 5. -1 plus 2 is a positive 1. 1 plus 5 gives me 6. All right, so 1, 6. Axis of symmetry, x equals 1. My maximum value, it's a downward parabola, right? So at the downward, if this is 1, 6, my maximum y value would be y equals 6, right? My minimum value, it goes down forever, so it would be infinite. My domain is all real numbers, and my range is going to be all values y is less than or equal to 6. Okay, and that's number 10. Moving on to number 11. It says identify and write the values of a, b, and c, then write each function in vertex form. All right, so we're going to take a lot of the same steps that we took in the last few problems, but then we're going to take a turn in a different direction. So I'm going to start off with here, and basically what it's saying is, all right, to take this from standard form, and I want this to go to vertex, I'll say form. Okay, so this is already in standard form. Let's change it to vertex form. And vertex form, once again, just to remind you, is y is equal to a times the quantity of x minus h squared plus k. And standard form was y equals a times x squared plus bx plus c. All right, so we want to change this. So we already have it in standard form. What do we do? Well, the first thing, it says identify a, b, and c. Okay, cool. A, B, and C. My A is 1, my B is a -4, and my C is 6. Cool, awesome. Got that. Now, what I want to do is I want to be able to find my vertex, right? My vertex is important, so I'll say vertex is equal to, and then I'll add this. And remember, in order to find the x is equal to -b over 2a. So -b, a -4 times a negative times a -4, and then 2 times 1. So negative times a negative is a positive, so it gives me 4. 2 times 1 is 2. 4 divided by 2 is 2. Cool. All right, so now that I have the 2, I'm going to substitute that into my original equation and say 2 squared minus 4 times 2 plus 6. All right, 2 squared is 4. Negative 4 times 2 is negative 8. Okay. 4 minus 8 is a negative 4. Okay, and negative 4 plus 6 is a positive 2. Okay, so my vertex is 2, 2. All right, so now that I'm here, I have my, think about it, and I need to write it as, remember in vertex form, y is equal to a times x minus h squared plus k. So here's what I need. I need my a, I need my h, and I need my k. Well, I have my a, I have my h, and I have my k. So all I do is y is equal to 1, so there's a 1 out in front, which I can just leave blank, right, because 1 times anything is itself. X minus, what was my h? 2 squared plus, what's my k? 2. And you're done. All right, moving on to the next one, number 12. All right, last problem. Y is equal to x squared plus 2x plus 5. First, identify A, B, and C. Okay, A is 1, B is 2, C is 5. All right, now that I have that, I want to find x is equal to negative b over 2a because I want to find my vertex. All right. That's where I'm going to put it eventually. So I'll say negative b over 2 times a. That gives me negative 2 times over negative 2 divided by 2, which gives me a negative 1. All right, negative 1. So I'm going to substitute that into the original equation. Negative 1 squared plus 2 times negative 1 plus 5. All right, so negative 1 squared is 1. 2 times negative 1 is a negative 2 plus 5. 1 minus 2 is a negative 1 plus 5. Negative 1 plus 5 is a positive 4. So my vertex is negative 1, 4. So once again, my h would be negative 1 and my k would be 4. And in my original vertex equation, y is equal to a times x minus h squared plus k. All right, my a, my h, and my k. My a is 1, so I still don't do anything. Right? Normally, if a is like 4 or something, then you put a 4 out in front, but it's not. It's just 1. 1 times anything is itself. So x minus, my h is negative 1, so I'm going to make it a positive 1 squared plus k. Okay, so final answer, y is equal to quantity of x plus 1 squared plus 4. And I've now converted this up here into vertex form. Pretty cool. So from standard form to vertex form. If you have any questions, please let me know.